That's what these postulates and axioms are talking about. So a postulate or axiom is a statement that is accepted as true. Okay, so if I say some kind of postulate, it is accepted as true. You don't need to prove it for it to be true. Okay, so postulates describe fundamental relationships in geometry. Basic ideas about points, lines, and planes are accepted without proof. So all of the theorems that I was talking about, so the right angle theorem, the Pythagorean theorem, all of those theorems you have to prove to be true in order to use it. Okay, so somebody proved that those are true using a paragraph proof, two-column proof, any type of proof, using these axioms. Okay, so axioms you don't have to prove true, or postulates you don't have to prove true. They're just accepted as the truth. So they are the building blocks of geometry. Okay, here are some postulates about points, lines, and planes. Okay, so we have postulate 2.1. No, I'm not going to make you memorize these different numbers on the outside. Okay, postulate 2.1 states through any 2 points there is exactly one line. So within proofs, you usually have a given and an outcome. So with this one, if you're given 2 points, okay, so you have 2 points, then you know that you'll have exactly one line. So that leads into exactly one line. So you can see that in the example on the right there. Line N is the only line through points P and R. Okay, that's the only line that goes through those 2 points. Can't have a different one. Okay, this one, 2.2. Through any 3 non-collinear points, there is exactly one plane. Okay, so given 3 non-collinear points, okay, so somebody said they gave you 3 non-collinear points, then you can say for a fact there has to be one plane through those. So that leads into one plane. So our example here, plane K is the only plane through non-collinear points A, B, and C. Okay, so A, B, and C, non-collinear, they don't lie in a straight line. Through those 3 points, plane K is the only plane through those 3 points. Okay, you can't have another plane on top of it, just like you can't have another line on top of a line. Okay, it's still the same line then. So this would still be the same plane if there's another one there. Okay, next is 2.3. So a line contains at least 2 points. So this time you're given a line. So this one has to do with a line just like 2.1 did, but 2.1 had to do with the points. This one has to do with the line itself. So given a line, it has to contain at least 2 points. It can contain more, but it has to contain at least 2. So the example on the right there, line N contains points P, Q, and R. Okay, so you have line N, it has to contain at least 2, however this one contains 3. Okay, it can't just contain 1. Do you have questions so far? No? Alright, 2.4 then, a plane contains at least 3 non-collinear points. So again, It's like 2.2, except this time you're given a plane. Okay, and you're talking about the plane. So this plane has to have at least 3 non-collinear points. Okay, so you can see that in the example on the right. So it has plane K. It contains those non-collinear points L, B, C, and E. Okay, it has at least 3 because there are 4. Okay, you can't just have 2. It has to have at least 3. Okay, so these two are talking about containing those points. These two are talking about it has to have those points to create that line or plane. Okay, so those first two are creating those. The other two are talking about the line and plane itself and containing points. All right, 2.5 then. If 2 points lie in a plane, then the entire line containing those points lies in that plane. So this one, you're given 2 points in a plane. Okay, so you have 2 points in your plane. Okay, so it tells you there's 2 points in that plane. Well, then you have to have a line in that plane because 2 points make up a line. So there has to be a line contained within that plane. Okay, so there has to be one line in that plane because there was 2 points in that plane. So an example, we have points A and B lie in plane K. Then line M would have to contain points A and B. So line M is in plane K. Okay, so since A and B lie in plane K, line M has to lie in plane K. Okay, we have 2 more. So 2.6, if 2 lines intersect, then their intersection is exactly 1 point. So this one you're given 2 lines. Okay, 2 lines will only ever intersect in 1 point. Okay, they will not intersect in 2 or more, only ever 1 point. Okay, so given 2 lines, you have 1 intersection point.
Good morning. Please excuse the interruption. All students with last names A through D that return the flu form can report to the comments at this time. Thank you.
So our example here off to the right, we have line S and line T intersect. Okay, so if those are intersecting, they are only intersecting at 1 point, and that 1 point would be point P. Okay? Last one is 2.7. So if 2 planes intersect, then their intersection is a line. Okay, so this one you're given 2 planes. Okay, so if you're given 2 planes and you know they're going to intersect, they will intersect in a line. So 2 lines intersect at a point, 2 planes have to intersect in a line. 2 planes cannot ever intersect at 1 point. Okay, it has to be a line. And you can see that in the picture here. So planes F and G are intersecting at line W. Okay, so you have those 2 points, at least, to make that line W there. Okay, they will never intersect in just 1 point. Okay, questions. Questions. All right, then we're going to do some examples using these postulates. Okay, so if you go to the back, we want to state the postulate that shows each statement true. So to state the postulate, you can just use the numbers that are next to it. So 2.1, 2.2, whatnot. Again, you don't have to memorize those for a quiz or test. Okay, you just have to kind of know what they mean. However, today we're going to use the numbers. So number 1, it says planes P and Q intersect in line R. So you have to go to the front and see which postulate you would compare that to. Okay, so you have 2 planes. You're given 2 planes and they're intersecting in a line. Which postulate is that? 2.7. Okay, you have 2 planes, given 2 planes, intersecting in one line. That's what 2.7 said. Okay, number 2, lines R and N intersect at point D. Okay, so you're given 2 lines intersecting at one point. 2.6. Okay, number 3 says line N contains points C, D, and E. It is 2.3. Okay, because it's containing those points. It's specifically talking about that line. Okay, so you're given that line, so it's containing those points. So it is 2.3.
Sorry, I couldn't quite hear you. Could you...
I didn't even say Siri and it went off. Okay, number 4, we have plane P contains points A, F, and D. So again, you have a plane containing points. So if we look to the front here, given a plane, it has to contain 3 non-collinear points. It is 2.4. Okay, then number 5, line N lies in plane Q. Line N, this one right here, it lies in plane Q. Talk to the person next to you. Which one is that? Planes intersect in a line. All right, what is it? It's 2.5. Okay, then number 6, line R is the only line through points A and D. Okay, so you have 2 points, and there's only one line through those 2 points. That is 2.1. Okay, so you had 2 points. There's only one line through those 2 points. Questions on any of those 6 problems? Okay, why decided that postulate was the right postulate? Do these kind of make sense?
Yeah.
Yeah? All right, then I'm going to have you do 7 and 8. Not that you need to use this, but it says here that segment AC, this means parallel. Okay, if you didn't know what that meant, that means parallel, that symbol there. It's parallel to segment DE. So you do need to then state the postulate that can be used to show each statement is true. So 7 and 8. Use the person sitting next to you to help you out. What are those 2 postulates?
Oh, yeah. Yeah,
Yeah, but there's like there are 2 points, so you could make a line on it and then a line on it, and that's 2.5.
so it's more like hypothetical.
It's 2 points wide.
What was that?
That was cool.
Hey, stop it now. All right. I'll wait a second.
Students with last names E through K that filled out the flu form, please report to the Commons at this time. Thank you.
All right, so number 7, a lot of you were going between 2.2 and 2.4, right? It is 2.2, it is not 2.4. Okay, so with 2.2, it does say you have to have those 3 non-collinear points. So this one's just read backwards. So it says exactly one plane contains points F, B, and E. So it is talking about those 3 non-collinear points. And then there's exactly one plane that has those points. So it is 2.2. Number 8, most people had this one right as I walked around. It is 2.5. Okay, you have those 2 points on that line, so that line has to lie in plane Q because those 2 points are in plane Q. All right, next. These problems right here are called sometimes, always, or never problems. Okay, so for it to be always, you can't think of a counterexample where that would work. Okay, for it to be sometimes, you can think of an example where it doesn't work and where it does work. And never, you can't think of any time where that statement would work. Okay, so these problems come up throughout all of geometry. Okay, so they're never going to go away. That's why I highlighted them. You have to know how to read each statement to answer that question. So I'm going to go through a couple with you, and then I'm going to have you do some. So with these ones, you're just using those postulates on the front. So in number 9, it says a line contains exactly one point. Okay, using those postulates, is that sometimes, always, or never true? Never. So I would write this is never true. Okay, so a line has to contain at least 2 points. It can never contain exactly 1 point. Okay, it has to contain at least 2. So I'd say this is never true. We'll do another one, number 10. So we have non-collinear points, R, S, and T, are contained in exactly one plane. Okay, this is saying they are non-collinear. There are 3 points. Are those contained in exactly one plane? Okay, would that be sometimes, always, or never true? It's always. Okay, that is always true. Okay, if you have 3 non-collinear points like this, okay, there's only one plane that can be drawn through those 3 points. Okay, if you drew another plane, it would contain 2 of them, maybe not the third one, but then that's not containing all of them. Okay, you can't draw a plane on top of a plane just like you can't draw a line on top of a line. Okay, so there's only exactly one plane that can go through those 3 non-collinear points. That's exactly what the postulate says on the front. Okay, so this is always. Okay, and I'll do one more with you, and then I'll have you do the last 3. So 11 says any 2 lines L and M intersect. Okay, L and M intersecting. Okay, can you think of an example where they do intersect? Yes, right? Can you think of an example where they don't intersect? When they're parallel. Okay, so meaning I thought of an example where this is true, and I thought of an example where this is not true. So this is your sometimes one. Okay, so this is sometimes true. Does that make sense? How to think about those? All right, I want you to try 12, 13, and 14. 12, 13, and 14. Can you have the homework sheet?
Yeah. Yeah, it's for grade. Geometry is not hard.
Or if I just mix up the colors, like, you know.
Say, I'm colorblind.
Yeah, it's like, how am I supposed to? You know, green should really. Green. Well, you're a Seahawks fan, why don't you?
Students with the last name L through P that turned in their flu form should report the comments at this time. Thank you.
That's color. They have colors. Here, I'm gonna put a plus, minus, and star.
But you don't write true, you write
All right, it looks like most people are finishing those last three problems. So I'm gonna go over them here really quick, and then I'll let you work on your assignment. If you want to do the last section there, 15 to 20, those ones are using your postulates from the front. Again, just labeling it like we did in the first section. So if you want more practice with that, you can do that section. Now, with number 12, it says if points G and H are contained in plane M. Okay, with this one, I'm going to draw a picture so you can see what's happening. So points G and H are contained in plane M. Okay, then it says segment GH is perpendicular to plane M. Is that true with my picture? Is GH perpendicular to M? It is not. Okay, it can never be perpendicular to M. Okay, because GH lie in M. Okay, those 2 points lie in M, so that segment has to lie in plane M. Okay, it can't be perpendicular to it. It has to lie in it. So this one is never true. Okay, 13. Planes R and S intersect at point T. What did I say about two planes intersecting? They have to intersect in a line. Okay, two planes can never intersect at one specific point. So So again, this one is never. Okay? You cannot ever intersect at one specific point. Two planes intersect in a line. Last one, 14. If points A, B, and C are non-collinear, then segments A, B, B, C, and CA are contained in exactly one plane. This one is always. Okay, so again, if you need to draw that picture, you have three non-collinear points. To make a plane, you have to have three non-collinear points. So there's one plane that goes through those 3 points. Okay, well, if those 3 points lie in that plane, then this segment has to lie in that plane. Segment BC has to lie in that plane. And segment CA has to lie in that plane. Okay, since those 3 points lie in that plane. Okay, their segments also have to. Okay, questions on these 3 problems for sometimes, always, or never? Then I do want you to work through the problems on that tan sheet that I gave you. If you want to know the answers to these ones here and you worked through them, okay, 15 was 2.6, 16 is 2.7, 17 is 2.2, 18 is 2.1, 19 is 2.2, and 20 is 2.6. Okay, so you can go back and look at why each of those are true. But again, those ones are just like that first section that we did at the top.